share some research on sort of fine ideas from philosophy of mathematics, which Carlo to a new field in economics. And this is really quite a novel and interesting development. So he's going to talk to something on this theme today. It's dynamic generation of hypotheses, Mandelbrot, Soros, and far from equilibrium. That's a more realistic approach to what financial markets are. Okay, so.
Thank you. So the title connects three important hypotheses about the behavior of financial markets. The hypothesis put forward by Mandelbrot, the one put forward by Soros, and the one put forward by a subset of economic physicists. And I will speak about the generation hypothesis using the stock market price trajectory, because I believe that it's a very rich case study of generation hypothesis. And it's very interesting because there are at least two different processes in generation hypothesis work. You will see the dynamic and the static. And these two different processes in generation hypothesis are able to generate several hypotheses about behavior of financial markets. So, first of all, I would like to introduce the problem of stock market prices. And the problem is to make sense of trajectories like this one. The problem is to make sense of this kind of object at a very different time scales. So here you can see a graph in time scales of months and years. Here you can see a graph of time scales in terms of days, and here you can see data coming out in terms of minutes and seconds. So the problem is how to interpret this kind of object. Yeah, the blue point, the points are the transactions. One of the most interesting aspects of the stock market price behavior is that the problem has two different sides. One the qualitative side and the other the quantitative side. The qualitative side of the problem requires to determine the variables affecting stock market prices. The problem here is that these variables are virtually infinite numbers. And they essentially are the result of the actions of investors who sell and buy stock shares. Simple. And the trajectories, in a sense, are the results of individual and collective decisions of investors that are able to move the price up and down. The investor behavior is based on a simple strategy to generate investment decisions, and this strategy is basically based on two rules. First rule, as you probably know, is if the investor, if you expect that the market is going up in the future, is to buy and hold the stock until the expected trend change direction. This is called the London market. The rule says that if investors hedge as the market is going down, it should stay out of it. Sell if you can by borrowing a stock and give it paid value by buying it at a smaller price in the future. This is called to be short. What's the problem here? The problem, as Donald knows, is that the stock market is essentially uncertain. Not risky.
Not just me.
Yeah.
Many people would it's well known.
And so the investors evaluate the valuations of companies' future profitability with them. And so it's very difficult to predict future directions of market prices, even if we are considering time scales of the order of decades, for which one could hope for a negligible influence of noise. So that's the description of the qualitative problem of stock market behavior. On the quantitative side, we have that price trajectories are an instance of the defeating problem. That is, we have here infinite mathematical possible solutions. That is an infinite amount of curves or equations, if you wish, that are able to approximate the data to forecast the next point of the curve. As we all know, adding a new point to the series doesn't resolve the problem, since the new series points cut off all classes of fitting curves. But even if you can do this, there are an infinite new curves an infinite amount of new curves that can approximate the new data. That's the problem. So there are a lot of hypotheses to solve this problem, and they can be broken down into two main approaches. The first one is the random walk approach. The second one is the non-random walk approach. The random walk approach is the one based on neoclassical view, and it is expressed by the so-called efficient market hypothesis. And we have at least three versions of these hypotheses. The weak one, the semi-strong, and the strong. The main idea in neoclassical view is that prices have a random behavior. This means that changes in information relevant to the future prospect arriving in unpredictable random fashion are responsible for the changes in the prices. So information coming from outside the market will change the prices. On the other side, the non-random walk approach maintains that prices trajectory are not random, and in the end they show some pattern. I will consider in my talk three hypotheses: the fractal market hypothesis before by Mandelbrot, the reflexive market hypothesis before Soros, and the self-equilibrium hypothesis before by the econophysicist, in particular by the Soros. I will try to compare these four different hypotheses using the most margin problem in price trajectories, that is, the nature and the occurrence of crashes and bubbles. Here you have an example of a bubble. This is the famous internet bubble, .com bubble. As you can see, there is a characteristic movement of the prices, so an upwards, an and then a downwards movement. And this is an example of a crash. Crash is a sudden drop in the prices behavior. It's in the graph you can see the gold crash in April 2013 this year. So let's start by analyzing the response of the efficient market deposit to this very puzzling problem. The efficient market deposit has put forward by two eminent economists, Milton Friedman and Gillies, and they answered to both sides of the problem, the qualitative and the quantitative. So they answered to the qualitative side is based on the description of investor behavior. And they say that the price variation in time depends on the action of traders. In a very specific way, investors take decisions that maximize their utility on the basis of expected return on risk. So the prices will be set by the equilibrium point between demand and supply. That's classical, neoclassical analysis. The prices will be the outcome of an earned investor that actively and rationally analyze all the information at their disposal and take investment decisions based on them. And the main point of the efficient market deposit is that these decisions have an immediate impact on the prices. This implies that any advantageous information that may lead to a profit opportunity is quickly eliminated by the feedback that investor actually earned in the price. So if such feedback action occurs instantaneously in ideal world or ideal markets without friction and costless trading, then prices must always fully reflect all available information, and no profit can be generated from information-based trading. This means that stock market volatility, it means the price variations, is generated by the random arrival of new information that affect the equilibrium value of the shares. So, the movement, according to the efficient market deposit, the movements of financial prices are an immediate and biased reflection of incoming news about future earning prospects. Now, let's see what are the main consequences of the efficient market deposit. The first one is that prices will tend towards equilibrium. So prices will be defined by the match between biased demand and supply. The second one is that you can't have a free lunch in financial market. That means no investment strategy can earn excess risk-adjusted average returns or average return greater than are warranted for its risk. So that means that markets cannot be beaten. You cannot profit too much from them. In fact, in a perfect capital market, price fluctuation reflects the random arrival of new information, and previous price trends are not relevant to the following ones. So, the markets are unpredictable and random. That's the main conclusion of efficient market hypothesis. It happens because as the market gets more and more active and efficient, the more intelligent and working are investors. So as a consequence, any advantageous information will be incorporated in the price, and then the more random is the sequence of price changes generated by such a market. So the randomness is doomed to increase. As concerns the quantitative size, the answer of the efficient market hypothesis problem is Brownian motion. That means the trajectories of price trajectory are a process, is a process that moves up and down in a random way, and the expected change of a given time interval is equal to 0. So that's the formula expressed as a typical express motion. So in the end, the trajectory is created, it's like tossing a coin. So ending with more or less the same number of things. And in a sense, in a specific way, the efficient market hypothesis is supported by an amount of data. And at first sight, it seems to be plausible and reliable. I will mention two characteristic data that are supporting the hypothesis. Distribution of daily returns and the correlation function of the returns at the minute time scale. The first one shows that positive and negative returns are almost identical, so that there is almost the same probability for a price to increase or decrease. It's like costing a time. So in this sense, they appear to be random, and there is no pattern. The second one shows that returns are essentially decorrelated beyond a few minutes in active and well-organized markets. As a consequence, according to Sonnet, successive returns cannot be predicted by linear extrapolation of the past. And there is another empirical finding that seems to support the hypothesis, and the finding is that on average and in the long run, even the best investors seems to be finding it out to be better than the comprehensive common stock averages. So the main consequence of this description of the behavior of the financial market is that, according to the efficient market hypothesis, there is no such thing as a speculative bubble. Because the presence of many sophisticated traders in the market will bust the bubble in the very beginning. But unfortunately, the efficient market hypothesis doesn't work at all. It's more or less a well-established fact now, but I will mention just a few data that seems to destroy this hypothesis. First one is that prices, data about prices move too much compared with what would be expected from the efficient market hypothesis, even corrected from the cost of gathering information. In effect, they do not follow normal distribution. Moreover, large price moves should only occur with significant geopolitical, economic, financial news, according to the efficient market hypothesis. But it is not true, because today there are a lot of flash crashes. I mean, crash occurring at a very short interval of time that are not dependent on news. So, my point in this paper is to show that these flows, the efficient market hypothesis, derive from the way of generating hypothesis. And the wave is, in a term, static. That is, aiming at integrating part of the data in a top-down schematic fashion, looking for rigor and compatibility with pre-existing and even theories and classical ones, rather than problem solving because of interpretation of the data. In a sense, the hypotheses rely on an opportunistic selection of the data. That means the data showing just the features that can be treated in terms of equilibrium and randomness. And these data and features are just the one suitable for a neoclassical interpretation, conceptualization, or modernization. So, the generation of the efficient market hypothesis is followed at least in two steps. The first one is that efficient market hypothesis can be successful, if possible, only when the features of data about price trajectory fit one of the stochastic process available, like the Brunner motions. But this conjecture is equivalent to the idea that stock market prices have no domain-specific features, or at least not features different from the stochastic ones. And the second flaw is, in the generation hypothesis, is that it is based on a trick, the accommodation of some features of the data within a classical view. In effect, part of the data are sacrificed to the hypothesis in a sense. In the sense that part of the data, like the large price variation and the frequency, is ignored in order to keep the rest of the data compatible with the classical framework. So, the efficient market hypothesis is carried out in such a way that it is seeking for the best available mathematics that available. It means already known, that can approximate part of the data and not the best hypothesis for all of the data in their features. So now let's have a look at the other hypothesis based on more random approach. And the first one is the fractal market hypothesis. The fractal market hypothesis generated by Mandelbrot answers only to the quantitative side. So, in 1963, Mandelbrot analyzed the series of contract prices on a time series starting in the 19th century, 20th century. This price series is very interesting because the prices do not follow normal distribution, and they show a peculiar set-similar pattern, which is indifferent to scale. It means that the Q described by price change for a single day is similar to the Q for months, for years, and so on. And so the fractal market hypothesis tries to start from the fact that large drops, bubble, and crosses in a discontinuous, dependent, concentrated, kind of fashion are normal outcomes for the dynamics of stock market prices. And they are not rare or extreme events. They're quite common. So the starting point of generation is a statistical domain-specific feature, which is then incorporated in a mathematical theory which shows how this trajectory can be approximated. And this mathematics shows, this new in a sense mathematics, shows that highly unstable dynamic systems that are able to generate stock market prices, which appear to be random, can be generated by the deterministic particles. In fact, a price trajectory can be extracted by the direction of up to the scale. So it's a typical equation from fractals to express the generation of the price trajectory. So in a fractal set, each number in the series is a simple but non-linear fraction of the purest number of units. And so the next number, the next point in the trajectory is not independent of all purest numbers. It's not like tossing a coin, and in stock market it is quite possible that each price movement is a complex function of previous price movement. So, the fractal market hypothesis offer a new statistical way to interpret the data so that some specific features of the stock market can be expressed, incorporated in the model. Moreover, in order to treat and model these new features, Mandelbrot had to build new mathematics which allows to approximate the data in a much more cogent and plausible way. What's the problem with the fractal market hypothesis? That you can have predictions because of the so-called sensitivity condition. So you cannot predict the market by fractal mathematics. In fact, after few iterations, the prices are not predictable. So you cannot beat the market with fractal approach. Moreover, the fractal market hypothesis doesn't give an answer to the qualitative side of the problem. That is, fractal market hypothesis doesn't offer an explanation of these new features and trajectories in terms of the behaviors and decisions of investors. So, there is one point that the fractal market hypothesis help to explain about the behavior of the investor. This point is that the fractal market hypothesis provides an explanation of the condition of stability of the markets. A market will be stable when it allows investors with different economic horizons to trade simultaneously. As a result, volatility, the fact that all investors are not the same, is a little part of this theory. We call it king. And this explanation is based on a very plausible assumption. The assumption is that investors can differ in their time horizon. This fact tells us also when instability is likely to be generated. Stability is likely to happen when all investors suddenly switch to the same time horizon. I would like to stress how this hypothesis is generated. And it's generated in a dynamic fashion. It is bottom-up, starting from the data and new features, and without an opportunistic selection of the data, and aiming at providing a plausible local interpretation of the data. And the hypothesis is the result of the manifestation of new features of stock market prices. And so there is no surprise, quoting again Gillies, that this hypothesis is more consistent with stock market data, more robust, and completely untamed by any assumption that the market is in or trend towards equilibrium. So in the fractal market hypothesis view, bubble and crushes occur quite often according to this hypothesis, since this hypothesis is built on the observation that bubbles and crushes are quite common outcomes of the dynamics of some market prices, and they are not so rare and common. Now, I would present to you the reflexive hypothesis, and what developed by Soros, titled The Alchemy of Finance in 1970s. The main idea is that prices can be affected by endogenous forces. So, by endogenous means the previous movements of prices. Soros provide an answer mainly to the qualitative side of the problem. It doesn't develop problems to the model. And they offer a new explanation for price trajectories in terms of investors' behavior. Moreover, his theory is based on a large verbal conception of modeling the stock market's behavior. So there is a verbal reasoning, not a numerical modalization of the stock market prices. So these hypotheses are receiving little scholarly attention, but really offer a penetrating view on stock market prices. According to Soros, markets exhibit continually, or not continuously, reflexive dynamics. It is a double feedback mechanism between investor expectations and price behavior, which can be observed and converted into profit. Yeah. So the reflexive market hypothesis conceptualizes and models the role of investors' expectation in price behavior. So quoting again Soros, as Soros has pointed out, market players are actors observing their own needs. That's the problem with stock market. And so the essence of stock market price, of stock market gain, reporting again Soros, is not to work out what particular shares are likely to be bought, but to work out what majority of other players are likely to think that the market will keep their route. So, the conceptualization offered by Soros is based on the idea of the incorporation of the two basic features of stock market behavior. The first one is that markets are always biased in one direction or another. They're not right. And the second one is that markets can influence events that they anticipate. These two features, these two new characteristics of behavior market prices imply that equilibrium, rational investor, demand and supply are not appropriate concept to the data in the behaviors of price trajectory. Soros, he says that I believe that market prices are always wrong in the sense that they present a biased view of the future. But this also works in both directions, not only to market participants, operate with a bias, but their bias can also influence the course of events. This might create the impression that markets anticipate future development accurately, but in fact it's not present expectation that correspond to future events, but future events that are shaped by present expectations. The participant perception are inherent to flow, and there is a two-way connection between flow perception and the actual course of events, which result in a lack, of correspondence between the two. I call this two-way connection reflexivity. So that's the definition that Soros gives of reflexivity. So Soros, in essence, is against the core idea of the efficient market hypothesis. So, which is stating that the trends we can observe in financial markets are merely temporary aberration, which will be eliminated in the long run by the fundamental forces of supply and demand. According to Soros, it ignores the possibility that there cannot be assurance that fundamental force will correct speculative excesses. It is just as possible that speculation will alter the fundamental conditions of supply and demand. In Soros of examples of activity at work that work like stock market and currency market, I will present to you only the first one, so the stock market. Soros selects some features that can be observed in the stock market and shows their reflexive connection, the consequence on the price behavior. These features are the so-called prevailing bias, and the second one is the underlying trends. These two characteristics. The first one, the prevailing bias, states that markets have many participants whose views are bound to differ. Many of the individual biases cancel each other out, leaving what they call the prevailing bias. The second one, the underlying trends, is a kind of force that influences the movement of stock market prices, whether it is recognized by investors or not. So the influence of stock market prices will vary depending on the market participants' view. So these two characteristics generate trends in stock market prices, but here comes reflexivity. Stock prices are determined by two factors, underlying trend and underlying bias, both of which are in turn influenced by stock prices. So the interplay between stock prices and the other two factors has no social what is supposed to be the dependent variable function is dependent variable in the other. Without a constant, there is no tendency towards equilibrium. The sequence of events is best interpreted as a process of historical change in which none of the variables, meaning stock prices, underlying trend, and prevailing bias, remain as it was before. In the typical sequence of these three variables, reinforcing each other in one direction, and this generates the most common pattern of the universal bubbles. And this the qualitative model constructed on Soros theory. So we have the reflexive hypothesis market. Reflexive market hypothesis allows to investigate other economic phenomena, promoting the formulation of new conception about possible relations between economic entities. These can be tested and can lead to discovering the field. Soros offers two interesting samples: the reflexive relation between credit and collateral and regulators in the economy related. So the explanation of bubble process offered by the reflexive hypothesis is quite causally plausible. According to Soros, they are normal outcomes of endogenous processes taking place by means of reflexive relation between the entities of the stock market. In this case, investors and their expectation decision. And in a boom bust sequence, we would expect to find at least one stress where rising prices are reinforced by a positive bias and another where falling prices are reinforced by a negative bias. There must also be a point where the underlying trend and the prevailing bias combine to reverse the trend in the stock price. And that's the zero of the question. So the hypothesis forward by Soros rely on dynamic generation. It is essentially bottom-up, starting from the data. There are a lot of reports in the book of the Alchemy findings. And these new empirical findings are incorporated in the verbal model. And we have new relations between variables and entities of the stock markets. And moreover, we have that there is an bias from even theories to formal theories, already known by the classical theory. So now we present to you the last hypothesis, which is trying to solve the problem. This is the far-fetching hypothesis. It relies on both the reflexive market hypothesis and factor market hypothesis. It's very interesting because it offers quantitative and qualitative response, an answer to the qualitative and quantitative side of the problem. As concerns the qualitative side, the hypothesis that these endogenous forces, the same before by Soros, are responsible for the dynamics. So, according to Queen about the harmful equilibrium hypothesis, who says that today's market price is a reaction to yesterday's price change. So, in essence, the Faffi's hypothesis is conjecturing that news about stock markets include the most present movement of stock prices themselves. So, he's stating that in today's stock market, the news will always be the most present movement in the stock price, rather than real news coming from so outside the stock market. And the main feature that the Faffi hypothesis is trying to incorporate is herding. So it means a critical emerging feature of the stock market is the existence of herd or crowd behavior in speculative markets, as carefully documented in the present book of Shearer and references. Herd behavior is often said to occur when many people take the same decision because some mimic the action of the other. And so, herding can be used to improve the findings of the fractal market hypothesis and reflection of the hypothesis and generate a quantitative model able to offer forecast. As a matter of fact, the dynamics of confidence and contagion decision making based on perfect information allow, according to Jeanette, to examine and answer critical issues such as the mechanism underlying crashes, the forecast of crashes, the control, the existence of fundamental instability in the world finance structure. And this hypothesis relies on a strong analogy between stock market prices and the critical points studied in the statistical field. But instead of the user interpretation of the efficient market hypothesis in which traders extract and constantly incorporate by their action all information contained in market prices, this hypothesis proposes that market as a whole exhibit emergent behavior not shared by any students. So, the long-term behavior of complex systems is often controlled by these rare and catastrophic events. And in the same way, financial crashes are able to destroy in an instant trillions of dollars, moreover, and shape the psychological state of investors and future. And the strategy of this, which is behind this hypothesis, is the prediction of detailed evolution of complex system, the prediction of the detailed evolution complex system is useless and even possible, but the prediction of phase of evolution of complex system is what really counts. So in a sense we can anticipate and forecast extreme events which are the main one. This forecast is possible and fruitful. And the view of Jeanette, which rely on Soros analysis, is that the crash has an endogenous origin, and that exogenous shocks only serve as a triggering factor. We proposed, according to Jeanette, that the origin of the crash is much more stable and is constructed progressively, increasingly, by the market as a whole. In this sense, it will be termed a systemic instability. So, in effect, according to the concept of critical points, any small perturbance may trigger the instability. That's the main point of the hypothesis. And one of the main advantages of this approach is that it allows an interpretation of classic bubble, while the classical model proposed for classes pondered the possible mechanisms to explain the collapse of the price of short time scales. So what is proposed that the underlying code of the class must be searched here before it for the class in the progressive acceleration of the market price, reflecting and increasing build-up of the market volatility. So, on the quantity side, the answer is a mathematical model with a log periodic structure, which is expressed by this equation. And this means that, according to Sonnet, the market anticipates the trust in a subtle, self-organized and cooperative fashion, hence releasing impulsory fingerprints. This can be observed in stock market prices. So, it is possible in a sense to predict trust and bubbles, and they did it several times. And it is possible if you allow that information and news incorporated by prices are the one concerning the present movement, recent movement of prices. And these may lead to deviation from two variations, simulating fast or up. So I'm going faster. For instance, Sonnet was able to predict several flash crashes or mining flash crashes, which are together like this one, where the time scale is in seconds. So, Sonnet's model is able to identify and predict flash crashes on the basis of quantification of the log at the level of the intermediate markets. So, last point of method is a reflection about the process of generation of this last hypothesis, which is dynamic. That means is optimal, starting from quantitative data and a new description of investors' behavior. So you rely on empirical findings like crowding. It combines qualitative and quantitative analysis, and moreover combines verbal models and mathematical models in a way. And it's able to tell us much about a way we can read the hypothesis. So I stop here.
Thank you very much.